This is Darrell with Cisco Training, episode 12. Today we're going to talk about RIPv2. As always, my web address is at web.mac.com/DarrellRoot. My email address is ciscotraining@mac.com, and here's my feed URL. Let's look at the RIP version 1 and 2 packet format. We have the command, we have the version, which is either 1 or 2, and then we have a series of RIP entries. Well, what is a RIP entry? The RIP entry is the information about a particular route advertisement in RIP. It has the address family identifier, which always just refers to IP version 4. And then in RIP version 1, we have the IPv4 address, which is the address of the route advertisement. And then we have a bunch of zeros, and then we have the metric. And the metric is the hop count between 1 and 15. A couple problems with RIP version 1, but the main problem with RIP version 1 is it's classful. It has no concept of subnetting. If you need to advertise 192.168.1.0/27, there's no way you can do it. All you do is you put 192.168.1.0 in the IP address, and you put your hop count down here. There's no way in RIP version 1 to say that, hey, I want to advertise a /27 instead of a /24. This is the RIP version 2 entry format. It's added in a subnet mask, which lets you put in that, hey, it's a 27 instead of a /24, and it's added in a next hop. The next hop, in RIP version 1, we didn't have a next hop. The next hop was always the router advertising the route advertisement. So if you get a RIP advertisement from the IP address 10.1.1.1, then your next hop was 10.1.1.1. In RIP version 2, that router at 10.1.1.1 can send a advertisement with saying, hey, instead of sending this traffic to this subnet to me, you can send it to 10.1.1.3 because he's actually closer. That's not used very often, but the advertisement of the subnet mask in RIP version 2 is critically important. Going back to the main packet format, we have the command, we have the version, which is either 1 or 2, and then we have RIP entries. Each RIP packet that is sent has multiple RIP entries in it, up to 25 RIP entries per packet. So that way, if you have 70 RIP routes in your routing system, you're going to need to send at least 3 RIP packets every 30 seconds when you send your RIP updates. To explain this a little bit better, let's get some hands-on, because again, this is Cisco hands-on training. So here's the network that we're going to work with here. This is similar, again, we have our top router, our left router, our right router, but we've changed up a couple things. We have different subnets. So up here we have a /26, here we have a /27, here we have a /24. In addition, we have different classful blocks. We have several different 192.168.1.2.3 class Cs that we're working inside of. And then we also have 172.16, which is a class B that we're working with. 172.16.1.0/24 is the subnet range we're working with. I've already configured my routers. Let's go ahead and look at the configuration on the top router. Okay, so my loopback address 192.168.1, interface loopback 0, IP address 192.168.1.1 / that's a /26. So the net mask is 255.255.255.192. And then for interface serial 0, IP address 192.168.2.1, 255.255.255.224, that's a /27. And then on serial 1, IP address 192.168.6.1, 255.255.255.0, that's a /24. This is my DCE interface on my serial link, so I set my clock rate to 64,000. And then in router RIP, I'm specifying version 1, and then I'm including the networks for each classful network that I'm working with. Because these are class Cs, it's 192.168.1.0, 192.168.2.0, and 192.168.6.0. I'm dealing with three distinct class Cs here, and then inside the class Cs I have my subnets, one of which is a /24, one of which is a /26, one of which is a /27. That's it for my config. That's running RIP version 1. Let's look at my show IP proto output. Show IP proto, or show IP protocol. Our routing protocol is RIP. We send updates every 30 seconds, which is the default in RIP. The next is due out in 18 seconds. Our timers for invalid after 180 seconds, hold down 180 seconds, flushed after 240 seconds. We have no outgoing or incoming filter lists for all interfaces. It says it's redistributing RIP, which just means, hey, if it's got routes in the RIP database, then it sends the routes out in the RIP advertisements. That's default. In fact, I don't even know if there's a way to turn that off. And then here's what's interesting. On each of our interfaces where we have RIP enabled, which is our 3 interfaces with IP addresses, because our network statements cover or include all 3 of those IP addresses, we are sending RIP version 1 and we are receiving RIP version 1. And then automatic network summarization is in effect. Maximum path 4. If we receive a route with an equal metric being hop count and RIP, from multiple directions, we will add those multiple directions into our routing table up to a maximum of 4. So if we receive the same route let's say we receive a route 10.0.0.0/8, and we receive it via 6 different next hops, we will only put 4 of those next hops into our routing table, because that is what our maximum path is configured for by default. I do not recommend increasing this, because oftentimes when you're working with routers that are optimized, like routers that have enabled Ceph, or some advanced routers have hardware, if you increase the number of maximum paths, then you can sometimes, the router will function, but it will process switch all of that. It might process switch that data. So it's really optimized for a maximum path of 4, and it's set to maximum path of 4. You don't want to mess with these defaults. Okay, routing for networks. We got our 3 network statements for our 3 class Cs, which we've activated routing in. We'll still pass on routing advertisements for IP address ranges that are not in these blocks. This is just which classful networks have we turned RIP on the local router. And then routing information sources. These are routers that we see as neighbors. And looking down at our map, 192.168.2.2 is a router that we will see RIP advertisements from on the top router. And 192.168.6.2 is another router that we will receive route advertisements from. So here we have a nice convenient list of all the routers that we've recently received RIP advertisements from, and the last update. This distance is the administrative distance. That is how believable the routing protocol is. RIP has a default administrative distance of 120. And here, because it's showing the distance on a per router basis, it's implying that we have the ability to control the administrative distance for these routes that we're receiving from each of these neighbors. And I believe that's true, but I don't know how to do it offhand. And then distance, our default administrative distance is 120, which is not particularly believable. Just about every other routing protocol is considered more advanced and refined than RIP, so just about every other routing protocol is more believable. For example, EIGRP has a administrative distance of 90. Again, with administrative distance, the lower the number, the more believable it is. So a static route, for example, has an administrative distance of 1 because a static route is completely believable. You know, you as a network administrator configured that static route for a reason. And a directly connected route has an administrative distance of 0, which is as low as it can go. Okay, so that is our network. We just looked at the show IP proto. Let's make sure that pinging is working. So let's ping 192.168.3.1, and I can ping it. I'm going to move my map off to the side. And let's ping 192.168.5.1. There it is. Let's do a debug IP RIP. And let's see what our route advertisements look like. We send them every 30 seconds. We receive them every 30 seconds. Let's see how long we have to wait. And there we are. No debug all. Let's go see what we captured. So there I typed no debug all. It said all possible debugging had been turned off. And then it showed out one additional debug. And that's to be expected. When you it takes a second or two for the no debug all to take effect. It's like that RIP advertisement might have already been received and it was just processing it and getting ready to print it out. Nothing to be afraid of. Okay. So, first thing, over here we have a timestamp, and this is the amount of time since the router booted. So I booted this router 38 minutes ago. There are commands to control it so that in your debugs it prints out the actual time of day based on the clock when you set it on your router, or you can have your router synchronized to a network time server, an NTP server. But these are just lab routers. I haven't set the clock. I haven't configured any of those commands. I don't have an NTP server on this network. So it's just, in that case, it's just telling me how much time since it booted up. We're sending a RIP. We're sending a version 1 update to 255.255.255.255 via loopback 0. So out the loopback 0 interface, we are sending a RIP advertisement, RIP version 1, to the IP broadcast address. This will be received by every host with an IP address on that subnet. Now that's the loopback interface. There actually isn't anything there, but that's but keep in mind, remember this IP address that we're sending the RIP version 1 update to, 255.255.255.255. That's an IP broadcast. It reaches everybody, whether they're a router or not. It could be just a host, a workstation that doesn't listen to RIP, doesn't care about RIP, and guess what? We just said, hey, here's some data for you to look at. And so that box is, so every box on that subnet is going to look at that data and use up some of their precious CPU to look at the data. And then realize, hey, that's RIP, I don't care about RIP. So we just wasted a bunch of hosts' time. And then here's the network updates that we sent out. We sent out 172.16.0.0 metric 2. That's interesting. Note, we don't have 172.16.0.0/16. We have 172.16.1.0/24 as a subnet down hanging off the left and the right routers. But we're sending the whole, an advertisement, which is just 172.16.0.0. That's it. That implies that it's a /16, but we never actually say it's a /16 in this advertisement because this is RIP version 1. We don't have a place to put the subnet information. So we just send to 172.16.0.0 and let the receiving router figure out what that means. And the only data that the receiving router has to figure out what that means is that it is is using the native classfulness. Since the first bit is 1, Since the first bit is 1 and the second bit is 0, that is a class B. The class B has a native subnet mask of native network mask of /16, so routers interpret this as a /16. And then we send our 192.168.2.0.3.0.5.0 and .6.0 with our various hop count metrics. What's interesting is that this is a /26 that we are sending it out. But those networks, 6.0 is a /24, 2.0 is a /27. Again, there's no information for any router that receives that data to know what the subnetting is there. So we could be very misleading. We could be saying, hey, you can reach this whole /20, we're sort of leading them to believe, hey, you can reach this /26 here, but the reality is that's a /27. Why are we leading them to believe that it's a /26? Well, we are advertising that out a /26. So, actually, these are different classful blocks. So, they will interpret it with the native classfulness. So, even though this is a /26, 192.168.1.0 is a different classful block than 192.168.2.0 because those are all class C's. So the 192.168.2.0 that we advertise will be interpreted as a /24 by any routers that we receive that information. Let's do an experiment. Conf t int lo1. I'm creating a second loopback address on this router. IP address 192.168.1.65, 255.255.255.192. No shut. I am adding, conf t int loopback 2, IP address 192.168.1.129.255.255.255.128. No shut. So what I just did is I created 2 additional loopback interfaces. So this router will now have 3 loopback interfaces in the same classful block. 2 of them are /26s, and 1 of them is a /25. Debug IP RIP. Let's see what happens with our RIP advertisements now. No debug all. Let's go back and see what we sent. So here is the advertisement out the loopback interface. And we created 2 new loopbacks. One was loopback 1, which had an IP address 192.168.1.65/26, and that got advertised. And the reason it got advertised is because the new loopback 1 that we created, let me update my diagram here. Copy. Loopback 1 is that 65, and loopback 2 is 129/27. Okay, so I have 3 subnets in the same classful block. The classful block is a /24 because this is a class C, and they have inconsistent subnet masks. 2 of them are a /26 and 1 of them is a /27. Okay, so, I'm sorry, this was a /25. So if I advertise this block, the 1.65 out loopback 0, any routers on the other side of that loopback, if there were, would be able to interpret that subnet as a /26 because those routers would be attached to loopback 0, which is a /26. So those routers would interpret the subnet inside this classful block correctly. So as a result, in Cisco iOS, it will send the advertisement out. But for loopback 2, this is a different subnet mask. So we're doing variable length subnet masks inside the same classful block, inside the same class C. So if we advertised this 192.168.1.128 out loopback 0, routers out there would interpret it as a /26, even though it is really a /25. So in effect, routers out there would be incorrectly interpreting the route advertisement. So to prevent the incorrect interpretation of routes, iOS will not advertise a /25 out a /26 in RIP version 1. More generally, if you're inside a classful block, it will only advertise out the subnet masks that match that subnet. So this is a /26, so the only thing that this router is going to advertise out are /26s inside this class C. Now for other class Cs, it's completely different. 192.168.2.0, that gets forwarded on. That's automatic summarization. It gets, in effect, would be treated by any receiving routers as a /24 because those routers have no information to interpret what the subnetting is inside the 192.168.2.0 class C, /24 class C. So that is why out loopback 0, we advertised our subnet that was also a /26, but we did not advertise our /27. But we did advertise our /27s in different classful blocks, but those were interpreted as a /24 by anything that was received there. So you can see some of the problems with RIP version 1 here. Because we don't advertise the subnet, we're having some because we don't have the subnet information in the RIP advertisement, it is it's confusing. So to avoid advertising incorrect information, or to avoid having the information that we do advertise interpreted incorrectly, we choose not to advertise the variable subnet masks inside a particular classful range. Okay, so how do we fix this? Well, the way to fix it was to improve the protocol, which is what RIP version 2 is all about. So before we go into RIP version 2, let's look at our routing table a little bit. Show IP route. So one route I want to show you is 772.16.0.0/16. We are on the top router. We are receiving, that route is for this subnet on the link between the left and the right routers at the bottom. We are receiving it from the left router here. We are receiving it from the right router here. It is one hop away in both directions, so it is equal cost in both directions. So we have one address block. Even though that's a /24, we interpret it as a /16 because it is a class B, and we have no information about how it is subnetted. We have two next hops for it. They are an equal metric away, one hop away in both directions, so we put both next hops in our routing table. And then the other 192.168.3.0, that's a /25 and a subnet, but we interpret it as a /24 because it's a different classful block, and we have no idea how that classful block is summarized. Is subnetted. Okay? So let's look, show run, pipe, begin, router, rip. This is my router with the more modern iOS, so I can actually do the show run, pipe, begin. Router rip version 1. Let's go back to the default rip configuration. So conf t router rip no version 1 end. So run, show run, pipe, begin, router rip. So now we're in a more default RIP configuration. Until now, we've always been explicitly configuring RIP version 1. But now it's just router RIP and then our 3 network statements. Let's do a show IP proto and see what we're doing. For RIP, even though we've changed the version of the protocol from version 1 to version 2, it's not like before when we redistributed between RIP and IGRP. In RIP and IGRP, we had completely different routing databases inside of our router. With RIP, it's the same routing database, whether you are using RIP version 1 or RIP version 2, or as you'll see here, a combination of them. It's one routing protocol, one database. When you're adjusting the RIP version, what you are adjusting is what advertisements, what protocol version you send, and what you receive. Well, we haven't really changed anything yet because we're still sending version 1, but we're willing to receive version 1 and version 2. Before, when I did RIP version 1, we were sending RIP version 1 and we were receiving only RIP version 1. So our advertisements will still all be version 1 and will not have changed. So let's try to change something. Conf t router RIP. Well, this default configuration where we're sending version 1 and receiving version 1 and 2, that's the default configuration. That's like where you're ready to migrate to RIP version 2. Because then if you start configuring routers with RIP version 2, then they will, all the routers out there are ready to receive it because the default configuration is that you're willing to receive RIP version 2. So let's go conf t router RIP version 2. Let's see what happens. Show IP proto. Now, we are sending only version 2 and we are receiving only version 2. So let's look at our route table. Show IP proto. Uh-oh, we've got a problem. Our last update was 40 seconds ago. And in RIP, we should be receiving an update every 30 seconds. So let's look at our show route table. Here is a route. The 172.16.0.0/16 route is now 55 seconds old. That's abnormal. We should be receiving that route advertisement every 30 seconds. What's happening here is that I have RIP version 2 configured on my top router and RIP version 1 configured on my left and right routers. So my left and right routers are sending me RIP version 1, are sending only RIP version 1 advertisements. But on my top router, I am only willing to receive RIP version 2 advertisements. So they send me the RIP version 1, and I'm not willing to receive RIP version 1, so I ignore it. So in effect, my routing protocol, my routing domain is messed up. And in a couple minutes, as soon as my timers expire, I'm going to expire those routes, and I won't be able to ping anymore between these routers, and then guess what? That'll be a network outage. So let's back out of our change. Conf t router RIP no version 2. Show IP proto. Okay. So I'm sending version 1. I'm receiving version 1 and 2. My last update was still 2 minutes and 9 seconds ago. Let's update again. Okay, now I got one of them received an update 4 seconds ago. Now I'm receiving now I'm listening to the RIP version 1 advertisements. And now I've received updates on both of them. Okay, normality has been restored. Okay, but you know, I haven't made much progress in migrating to RIP version 2 here. Let's try something, well, let's get all of our routers. The right way to do this is to get all of our routers to the default configuration where everybody's sending version 1 but willing to receive version 1 and 2. Conf T, router RIP, no version 1, which gets us back to show run type begin router RIP. This router is a little bit older, so it can't do the pipe begin. So now router RIP, and I just have my network statements. And then my bottom router, or my right router. Conf T router RIP, no version 1. Show IP proto. So now I'm sending version 1, I'm willing to receive version 1 and 2. Now, let's go back to my top router, conf. So now all my guys have the default configuration. They're all sending version 1. They're all willing to receive versions 1 and 2. Conf T, let's try router RIP version 2. Let's see what happens now. Show IP proto. So now I'm only willing to send version 2, I'm only willing to receive version 2. Let's do a show IP proto again. Uh-oh, same problem again. 35 seconds since the last update. Okay, well, you know, I've still got the same problem because the left and right routers are still sending only version, they're willing to receive version 2, but they're only sending version 1. So, and I'm not willing to accept version 1. I'm not receiving version 1. So, let's back out of that change. Conf T, router RIP, no version 2. So what we want to do is we want all the routers are willing to listen to version 2, but not everybody's, but everybody's only sending version 1. What we want to do is we want to start sending version 2 advertisements. So conf T router RIP send, let's see, version 2. Okay, I found the command conf T int serial 0 IP RIP send version 2 int, what was that? Was that serial 0? Yeah. Int serial 1 IP RIP send version 2 and show IP proto. So now on my loopback interfaces, which don't really go anywhere, I'm still sending version 1, and that's not a big deal because they don't really go anywhere. But for my serial interfaces, I am sending RIP version 2. And the other routers are willing to receive RIP version 2 because they have the default configuration where they're willing to receive version 1 and version 2. So let's go to one of those routers and take a look. Let's go to the left router, show IP proto, and you can see both of the routers, including this is the router, received an update 4 seconds ago. I'm still sending version 1, but I'm receiving version 1 and 2, so conf T int serial 0 IP RIP send version 2 int serial 1 IP RIP send version 2. And here, note the syntax here. RIP is, in the interface configuration, RIP is a sort of like it's like a child of IP. there are other protocols besides IP in the world. They're not really used much anymore. Apple Talk is one. But so you've got the address family IP. RIP is a routing protocol, which is part of IP, and then we're sending version 2. And then let's go to the right router. Show IP proto. And I'm still sending version 1. I'm receiving version 1 and 2. I have an update recently from the left router and from the top router. So conf t int serial 0 IP rip send version 2 IP rip. I'm sorry, int serial 1 IP rip send version 2. Okay, so now in my triangle of routers, I have configured every router to be sending version 2 on every interface, which actually goes to another router. And so now if I do a show IP proto, I can see I'm still getting recent updates. Show IP route. My route table looks complete. I ping 192.168.1.1. Let's debug IP RIP. And let's see what kind of advertisements we're getting. So we've received our 2 updates. Let's wait till we send an update. No debug all. Okay. So here's an update we received. Note the syntax has changed a bit here. It includes the IP address, the subnet mask, the next, this is the next hop, but the next hop is listed as zeros, which means that we go as a next hop to whatever router we send that we received that from, which means our next hop is 192.168.6.1. So here's the 192.168.6.1. He sent us the advertisement. In the next hop part of the RIP advertisement, the next hop was all zeros. So we interpret that to mean that 192.168.6.1 is my next hop for those route advertisements for these /24s. And then from our other neighbor, we received these route advertisements, these /24s, and then we sent a version 1 update out our loopback interface. Now I didn't configure, on the loopback interfaces, since they don't really go anywhere, I did not configure send IP rip send version 2 on those. So we sent rip version 1, and you can see there's no subnet mask in that in those advertisements. And then we sent a v2 update out serial 0, and this is interesting. The IP address that we sent it to is 224.0.0.9, which is different from the IP broadcast address in RIP version 1. This is another difference of RIP version 2. In RIP version 2, there is a multicast address that routers that run RIP version 2 subscribe to. That multicast address is 224.0.0.9. When we send out the RIP update on the wire, on the Ethernet, or actually this isn't Ethernet, this is serial, but if it were Ethernet, we would send it out to, we're sending it to an IP multicast address. So on the Ethernet, that would get translated into an Ethernet multicast address, and only the beauty of that is only the hosts that subscribe to that multicast address will actually receive the packet and interrupt the CPU on those hosts. So if you have a network with 100 hosts on them and 3 of them are routers which are subscribed to this multicast address, then only those 3 routers will burn up CPU processing your RIP advertisement, and the other 97 hosts will not burn up CPU because their network interface card will not interrupt the CPU on the host. This is an advantage of RIP version 2. It's more efficient for the network to only bother the devices on the network that really care. In addition, we also have the subnetting. One interesting thing here, though, here is an advertisement out serial 0, which for 172.16.1.0/24, but we're not advertising 172.16.1.0/24. We are still advertising 172.16.0.0/16. We are advertising the whole class B, even though now that this is RIP version 2, we don't need to. This is RIP version 2. We can tell exactly what we can advertise the precise subnet if we want to, but we're not. We're advertising the whole class B. That is called automatic summarization. In RIP version 1, we didn't have a choice. We had to automatically summarize. In RIP version 2, we have the choice, but for backwards compatibility, we automatically summarize by default. This is incredibly dangerous. When we send out route advertisements, we are promising that we can deliver packets to any IP address in this range. We are promising that we can deliver the packet to any IP address inside 172.16.0.0/16. And in this case, we are incorrect. We are lying. We cannot deliver the packets to anything other than the /24. So automatic summarization, it's enabled by default in RIP. It's also in RIP version 2. You have no choice in RIP version 1. You have to do it. EIGRP is an advanced routing protocol, but EIGRP also does automatic summarization, and that's caused several network outages, that I'm aware of in my past. That automatic summarization is bad, so let's turn it off. Conf T router RIP no auto -sum. So run. So router RIP no auto -summary is now part of the config. I recommend that you add no auto -summary to your standard config for RIP, all routers that you deploy for RIP version 2 and EIGRP for the rest of your lives. No auto summarization. Don't summarize by default. Summarization is sometimes useful to minimize route advertisements, because if you have too many route advertisements, then you can melt down your routing protocol. But you want to, as a network engineer, it is your job to choose to summarize, not let the router choose to summarize for you whenever it wants. Where will the router automatically summarize? Whenever there is a classful network boundary. This is a classful network boundary because this is a class B, 172.16.0.0/16 class B, and this is 192.168.6.0, which is a class C. So this class B address space will automatically be summarized going out when it's advertised out serial 0, and 192.168.6.0/24 will be automatically summarized as the /24 when it goes out serial, when the RIP advertisement goes out serial 1. Automatic summarization is dangerous. Turn it off. No auto -summary in all your standard configs. Let's see what effect that had. Let's debug IP RIP. And we wait for up to 30 seconds. And there it is. No debug all. Okay, and here you can see the effect of the no auto summarization. 172.16.1.0/24 is now being advertised out serial 0. So we are only advertising the block that we promise we can get to. Okay? And let's do a show IP route. let's do an experiment. Let's go over to the, that is the right router. Let's go over to the left router and turn off automatic summarization there. Actually, let's see what kind of config we got, because I've forgotten where we are in this router. Okay, so we are sending version 2. So conf t router rip no auto. Since we're sending version 2 on all of our routers and we're willing to receive version 1 and version 2, we can complete the RIP migration on this router by going version 2 without impact. And then I can also do the no auto dash sum debug IP rip. Let's see what kind of advertisements we're sending out. So we sent a advertisement out, serial 1, which had 172.16.1.0/24. The next hop is 0000, which means send it to me. Now what's interesting is both routers that are originating 172.16.0.0/16 are done, but the route sort of lives on because the top router received the route from the left router and from the right router, and so it's passing on the route advertisements. Let's watch our debugs for a little bit more. Interesting. Ignored a version 2 packet from 192.168.3.1. Oh, that's our loopback. So that's what loopbacks do. You send out the advertisement, you receive it looped back. Okay, and there we are. It's this route, 170.16.0.0/16, is still living on as a metric of 3. It's going to take a while before it disappears. So that's another example of the danger of auto summarization. No debug all. This route that was incorrectly advertised before is going to hang around for the full timeout of 540 seconds in RIP before it goes away. So you mess up, you automatically summarize for a little bit, you correct it, well guess what, your network's still impacted for several minutes while RIP converges. Okay, that concludes our talk about RIP version 2 today. Thank you.